Hello, everyone. I can see people already joined the room. I'm not sure if you saw the meeting before the live started, but we are now live. So welcome to our audience after a break. This is the first webinar of 2025, and also welcome to my guest. Today we have very interesting topic, in my opinion. It's also very important topic for us as laureate, as we embraced this hybrid approach. So we are not using one single technology protocol, but we use two protocols, and we will know more about this today. And I will introduce briefly the topic of today and our speakers, so that we also give more time for people to join in. I'm Dario Macarona, I'm CMO at Laureate. I'm the pleasure to be again once more the host of this webinar. And today we are talking about, as you can see from the title, this hybrid approach. So what is it? We go with we are of course in the LPWAN realm, and we are combining in this workshop, and hopefully in many use cases as well, LoRaWAN and Mioty. So we are discussing today with our speakers what are the advantages of going with two technologies instead of only one, with all the challenges as well, and what we expect, what we have to take into account. We will put a special focus on Mioty today because, of course, this is a new technology and probably, well, not probably, but for sure, less known than LoRaWAN. We already know very well LoRaWAN, and a lot of document and details are available already about LoRaWAN. And of course, everybody knows that how good is LoRaWAN in the LPWAN environment, and how it's a great choice for many use cases. So we dedicate a little bit more time talking about Mioty and what makes this protocol peculiar and special in its own way. So and we also see some, let's say, new features, new peculiarities of Mioty that just recently came out. Together with me, I'm happy to introduce Liliane Paradise, Head of Operation and Innovation at Miromico. Miromico is a company that is one of the best in creating micro chips, and is especially strong in in the hardware manufacturing space. It's a Swiss company as well as Laureate, and Liliane was leading the hardware team for some time at Miromico, and then recently she has taken the role of Head of Operation and Innovation. She also very well known in the ecosystem as a speaker at events. She was one of also the speakers at our last IoT Sparks event last September. So I'm very happy to have her with us today. And next to her, you already can see his face. He's Stefan Ereth. He's group manager of Fraunhofer IIS, and he was, I say, one of the pioneer in the Mioty technology long before we all heard for the first time this name. Was already working on it, so he's real expert and is probably the best person today to introduce this technology and go into details for you to understand more, to learn more about this technology, and of course about the hybrid approach and how it can help reach your IoT goals in 2025 and later. So I don't want to spend more time. Again, welcome. Just a reminder for everyone, you can use the chat and the Q&A session. You should see the little icons in your window. So just please use it. And this was something we were talking before starting with Liliane. Of course, they are gonna present the topic the best way they can, but it would be good if you want to go into more technical details, or you need a little bit more simple um, simple description and so on. You can also share in the chat. This is also a good point to make connection out of this webinar. You can share in the chat your position if you are more in the technical side or in the business side. So please don't be shy and use the tools we have. We will be again together at the end of this webinar for the Q&A session. So let's start. I hand over to Liliane. Welcome again to the speakers, and enjoy the webinar.
So welcome everyone, also from my side, and Happy New Year, of course. It's a pleasure to be here and to be able to present to you. Let's start with a little bit of motivation before we dive into the actual technical topic. We are in 2025 and IoT is literally everywhere. It's spread across all different industries. And the beautiful thing about IoT is that it could be literally anything that connects things. It could be as simple as reading a few temperature values to highly complex systems that consist of not only sensors, but also actuators that depend on each other. Needless to say that all industries have different demands in terms of scalability, of cost effectiveness, of energy efficiency, data throughput, and of course also of the diversity and availability of the ecosystem. Now, let's take smart city as an example. I really like smart city as an example because, again, smart city is a very loose definition of a use case or a market, if you want to say so. It can, again, be anything from like a small village that has a first use case, maybe reading some temperature values, to a big city, like imagine New York City, that basically has a use case hidden at every single corner. And as much as every single city, every village, of course, is unique, so are its demands in terms of smartness, and especially also so is the diversity of the availability of budget, for example, for digitalization and change management. Now, smart city may be one of the most challenging markets because it has a loose definition. As said, it could be any kind of use case, and usually it lacks of a standard. Besides that, in the past, we have seen many cities, smaller and larger ones, that managed to roll out a sufficient coverage with only a handful of LPWAN gateways. Usually in a smart city scenario, in many of the use cases, either the sensors are installed outdoors or they are at least installed above the ground when they are installed indoors. So usually penetration is less of a concern than actually cost effectiveness. Usually cities or municipalities are on a budget. And of course, that means that it's super important to have a diversity of sensor available and available off the shelf as finished products, rather than having to invest in too much CapEx and engineering costs. But now if we take a zoom in and we look into one specific, if you want to say so, subset of smart city, namely smart metering, that might look completely different. When we talk about smart metering, it's important to understand that the metering industry is generally more conservative, and it already has its own standards, such as OMS and wireless MBUS. So anything that cannot fit into that standard will be really tricky to integrate. And then, of course, there is the demand for high quality of service, which is especially challenging because usually we have a deep penetration scenario. The sensors are installed below the ground. And of course, when we are talking about metering, that might mean multiple meters per house, and we're talking about a massive number of devices. This zoom in from a more general use case of like smart city to smart metering demonstrate how diverse and sometimes also unpredictable the requirements for a connectivity or an infrastructure can be. And in reality, there may not be one solution that fits everything. Since the future is unpredictable, why not go hybrid? In today's webinar, we will focus mainly on two LPWAN technologies. On one hand, we have LoRaWAN, which I believe most of you are very familiar with. Of course, it's one of the most mature LPWAN technologies. It has a super rich off-the-shelf ecosystem of devices and enables long range and super low power consumption. And then, of course, we'll be treating Mioty, which will be introduced by Stefan.
Hello also from my side. I'm pleased to explain a few details of the IoT technology to you today. So what's the secret behind Mioty? And the secret behind Mioty is the telegram splitting technology. Normally when you have when you do a transmission and you want to cover a long distance, then you transmit very slowly and therefore end up with a very long telegram. And then if you have interference in the same band, it's very likely to be interfered. And therefore at Mioty we use the telegram splitting technology. We cut the long telegram into several pieces and we spread them over frequency and time so that it's less likely that all packets are interfered by one interferer at the same time. And then we have a forward error correction inside, and if half of the packets make it through to the base station, then the base station is capable of receiving the telegram and restore the missing information. Like LoRaWAN, Mioty works in the sub-gigahertz band, so in Europe on 868 MHz and in US at 950. And it's optimized for battery operation. Especially the short bursts are very battery friendly, that you don't need so much energy. Here you can see the technology features and the business benefits. From the technology point, we have high range. We have like 5 kilometers coverage in urban areas or 15 kilometer in rural areas. Then it's very power efficient, where you can build sensors with up to 20 years of battery lifetime. Also, the scalability is great, also because of the telegram splitting system. We can receive 3.5 million messages per day with one Mioty base station. Also, Mioty is capable of dealing with mobility. It works up to 120 kilometers. Its worldwide operation is possible in the sub-gigahertz free band, and it's in standard. It's standardized by the ETSI standardization, so everybody is capable of participating and building their own sensor devices. Like LoRaWAN, you can also have private networks with your own base stations, or you can put them all together to one big coverage. So what are the challenges in hybrid networks, which meets the topics of today's meetings? You see here on the right, we have a spectrogram with the frequency on the x-axis and the time over the y-axis, and you see the different technologies. When you have LoRaWAN, it's a chirp spectrum, which takes a huge amount of space in the spectrum. Then you have Sigfox with very long telegrams that are easy to interfere. And then you have Mioty with a lot of small dots in between of them. And if you want to build a hybrid network, then you need to receive more than one waveform, of course. So you can build base stations that are capable of receiving LoRaWAN and Mioty at the same time, but it's a bit more challenging. The next thing is, of course, we are in the license-free band, so there is a lot of noise, and we will get even more noise in the future, not only from your system, but also from outside the world. Other systems could be installed in the same city or in the same area. So there's also challenges, and it's good to have something that is reliable. On LoRaWAN, you can switch between the 8 channels to get away from noise and search for a band that is not so noisy anymore, which is normally done by the LoRaWAN network server. And on Mioty, you just rely on the forward error correction and the telegram splitting to get through this noisy environment.
So now that we have heard about a few challenges, let's have a look at what are some key aspects to get a successful hybrid connectivity. And one of the most crucial things to consider is interoperability. I cannot point that out enough. When you build a hybrid system, that really starts from the sensor to the cloud. So we at Miromico, we are a hardware company. And for example, when we build hybrid systems, we make sure that even the sensor payload for a LoRaWAN and the Mioty device would be as similar as possible. And of course, that doesn't just apply for the node, that should go through the base station level to the network management up to the cloud, such that the system doesn't behave like two systems and you have to manage and support two different systems, but it ideally behaves as one unified system. Then, of course, what's very critical is the selection of the proper technology for each use case. Of course, that has to be evaluated from use case to use case. It depends a little bit how much of ecosystem availability you will need, how many devices you expect to have, how noisy or challenging the environment is, and so on. And then lastly, it's super important to not just think for now, but to think about the future and to choose future-proof quality components with a high level of adaptability, because as we will hear also in the end, the technologies are not sleeping. LPWAN and IoT in general is a fast-moving sector, so we need to be prepared for the future and don't just build for today. Some strategy to get to the success are to plan from the very beginning for the scalability. So don't just think today or tomorrow I will have 100 or 1,000 devices for my POC, but actually start to plan with the worst, or if you want to say so, best case scenario, how many devices must I support? What will be the challenges? And plan that in the very early phase. Then, of course, it's crucial to consider the total cost of ownership from the beginning, which technology makes sense in which case, and start the network planning in an early stage. There are companies that offer tools for that in order to allow for strategic network planning, because you might not need a hybrid coverage everywhere. In general, you will require less Mioty base stations than you will require LoRaWAN base stations. Then, of course, reuse existing infrastructure and make sure to get the skills, or to get the people who have the skills to do an informed decision making. Now, what does an informed decision making mean? We will zoom a bit into the view of gateways, because that's also something that we do at Miromico. Now, when we look at hybrid connectivity gateways, in the first moment, that seems like only a charm, right? We have only one box. That means simplified deployment, lower infrastructure cost, also lower installation and maintenance cost, easier fleet management because we have only one centralized interface, and then also simpler network planning because we're essentially only planning one network, not two. Now, if we look a little bit closer at the technical details, that comes with some additional complexities. One of them is a complexity with TX, with sending, especially if we have only one antenna, because when we can send, of course, depends on when the devices will send an uplink, then we have a certain window where we can send the downlink, and these might collide. So one has to think about how do we prioritize in case of a collision. Then, of course, compliance is a topic. Duty cycle, when we have one box, we get the duty cycle per box. So this needs to be taken into consideration as well. And then, of course, also interference so that the technologies don't disturb each other. Another point to consider is that there is an additional security risk, because there is a single point of failure. So you will not have the redundancy that when one coverage fails or one device fails, that the other one is still up and running. And then, of course, it gives you kind of a limited customization and scalability in some cases, because you might not need to build a hybrid coverage in every location. I'd like to zoom into two specific scenarios that I believe are realistic scenarios. One of them is that there is an existing LoRaWAN coverage, because many cities across the world already successfully built a LoRaWAN infrastructure. First of all, don't scrap a working system. Why would you tear down perfectly working LoRaWAN gateways just to replace them with hybrid ones? That would be a waste of time and money in many cases. The next thing to consider would be, how can I retrofit the hardware? The good news is, if we can decide that unidirectional is sufficient for our use case, then we might be able to use our existing end nodes, because with every Semtech or LoRaWAN capable radio chip, you can do unidirectional Mioty communication as well. So you will just need to do a firmware update to get hybrid hardware. And then on the other hand, we have the base stations. For the base stations, it's a little bit different to the current point of time. This is not compatible, but if we have a good existing base hardware platform, such as a Linux board that we already know, we can save a lot of development efforts by making use of extensions, such as, for example, using the standard mini PCIe cards that we provide in order to add Mioty through a standard interface to an existing gateway. Then for the coverage, our tip is to do the same, extension instead of replacement. So instead of adding a ton of new gateways, one might just say, I will build an additional Mioty coverage because the LoRaWAN coverage is already available. And then, of course, on the software part, the extensions should be done in terms of interoperability, such that it behaves as one system. The other scenario is when you start from zero. That's when you get to do everything right from the beginning, hopefully. And then, of course, one should start with the network planning. And a tip there would be to plan a hybrid coverage at certain strategic locations. So you might want to start with basically planning the Mioty coverage, and wherever you plan a Mioty coverage, you can plan a hybrid coverage, and then later you can add densification for the LoRaWAN coverage in order, for example, to improve adaptive data rate. For the component selection, we would recommend hybrid base stations or a mix. So a mix of hybrid and maybe some LoRaWAN only gateways. And the other important factor, and that doesn't only mean for a hybrid strategy, but in any case, when you're planning a new infrastructure, a new coverage, to consider security from the sensor to the cloud. This topic, for the ones who are familiar with the Cyber Resilience Act, this topic will haunt us for the next few years. So that's something that should be considered from now on very intensively. Then, of course, to go for performance and reliability, and most importantly, also updatability, because as we will learn from Stefan in a second, LPWAN is not sleeping, and we will hear about many new exciting features.
Thanks. In the last part, I will tell you about new features in LPWAN. So we have OMS LPWAN. OMS is very popular in smart meter, and because it's mainly on the application layer, and it's a tender-driven business. So if the cities want to use OMS, it's good to support it. You have two options, either with Mioty splitting mode or with LoRaWAN also. So the OMS group has recently released their Gen 5 specification, and they added the splitting mode, OMS 5 splitting, which is the same as the Mioty in ETSI, and we call it Mioty for OMS. And there's also an application layer specification for LoRaWAN network architecture available. It's called OMS over LoRaWAN. And for the Mioty technology, there's a new release of the ETSI specification, which is the baseline for the Mioty protocol. And there are some pretty cool new features. Mioty now also supports synchronous downlink transmissions with class B and C. And with that, you can do multicast transmissions to control multiple devices at the same time or to transfer a large amount of data to the devices. And it now has also a new data rate mode with higher data rates in uplink and downlink. The next slide, I present you the different classes that we support. It's more or less the same classes like in LoRa with class A, B, and C, but Mioty also has the class Z, which is uplink only. You may ask why use uplink only, because uplink only is the state where you can live the longest with one battery, because you don't need to receive anywhere. And we use class Z typically for collecting data for sensors. We always use the highest reach mode, so we don't do adaptive data rate. And therefore, for pure sensors, you don't need any class Zs, any downlinks. So for class A, it's typically you have a downlink after the uplink. You can do acknowledgement of uplinks receptions. You can transmit commands to each device individually. Then with the new ETSI standard, we have also class B and C. In class B, it's the beacon mode. The base station periodically transmit beacons, and in those beacons, it's scheduled when the next downlink will happen and to which devices or to what group of devices. So multicast is now possible. There you can do first control things or transport large amount of data. And class C is more or less immediate downlink. There you can do device activation, low delay control, and this supports also multicast. In Mioty, we have with the telegram splitting mode also a cool feature, which we call quasi-duplex operation. Normally, when you have a base station, you can't transmit and receive at the same time. And now, when downlink rates go up, it's likely that you transmit a downlink while receiving an uplink, and you miss the uplink therefore, and it's quite bad. In Mioty, it's not so bad because we use telegram splitting in the downlink and in the uplink, and we have multiple packet bursts there for the uplink and for the downlink, which with different time intervals in between. So it's very unlikely that for one uplink, all uplink bursts get lost. And so with the error correction, it's very likely that you also have the uplink received at the end of the time. Even if your base station is doing a 10% duty cycle, which is normally allowed, then you can receive also your Mioty data. So now we're coming to the end of our webinar, and we want to give you a short summary. For the smart city and smart metering applications, they are growing hybrid LPWAN systems to support the future demands. And what's really important there is network scalability, because device density in smart city networks will increase over time, and there will be more and more sensors to meet the demands. Then we have the thing extension of instead of replacement. If you plan to build hybrid, don't throw away your old network, just extend the network with hybrid base stations or replace some key points and go to a hybrid network server. Then you have a future-proof and your interoperability of software. Reliability is really important. Smart metering applications require high packet delivery rate, typically one long package at least once per hour, and that from 95% of all devices. So you really need to receive all messages and can't throw away a lot of them. Then a good thing always is build versus buy. We have a good ecosystem in the LoRaWAN Alliance, and also in the Mioty Alliance, the devices are growing and growing from each day. So a lot of things are already available. If you want to use something, just check before you build something if there is already something available. And the last thing, we have the new Mioty next generation. We have a new version available with the ETSI standard, which addresses upcoming demands of future IoT networks. And with this, I hand back to Dario.
Thank you, guys. It was very interesting. I would like to stay a little bit more. Let me take control back for the thanks. I'll stay a little bit more on this slide because I think it's a nice summary. Thank you. Someone from the audience is sending applause, and this is all for you guys, for our speakers. Now I would like to engage with our audience. I think this summary is very, very helpful because it gives tips from also common sense. This is extension instead of replacement is extremely important, and build versus buy is also very important because I mean, this is common sense, and this way you prevent a lot of problem, because if you rely on solutions that are already in the market, that are already been tested, not just the components, sometimes also the end-to-end solutions, you avoid a lot of headaches. So now I would like to, well, again, thank you. Please, from our audience, and tell me if you want to go back to a specific slide, or if you have questions for our speakers. Oh, I can see there is already list one. Let me, okay. Yeah, there is a question from Willite Kevin. I hope I pronounced the name correctly. Is Mioty already being used in real-world applications? This is the question, and I don't know who wants to answer. This, I think, is for both of you.
Yes, of course it is, especially in the metering domain. For those who are interested, for example, the metering has quite already a few meters in the field. I see actually someone from metering is in the loop. So if you wanna say something to that, but yes, Mioty is already being used.
Stefan, do you want to share any other use case you know about?
Yeah, with Mioty, metering is definitely the most prominent one, with millions of devices. And with Mioty, you don't have a lot of nationwide networks already available. Typically, the cities install their own networks, and then they start with the typical city use cases. But we also have a lot of feedback from industrial use cases, where they start in the automotive sector or in the building industry to get more and more data. Also, energy consumption is important to calculate the CO2 footprint, or temperature values. Knowing exactly what goes on in the factory is really important for today's.
Thank you. I hope we answer your question, and I encourage other attendees to ask their own question, doubt, or if they want our speakers to go back to a specific topic that they mentioned before, and they want to have a look again. One thing that I wanted to comment is that this is something we always say, is now when our customers or clients, they ask us about LoRaWAN Mioty, and we always say that there is no one technology that let's say if it is all. No, it's like we usually do this this metaphor of the car. Which car is the best, depending where you're going. But in general, we are really fan of this hybrid approach, and what we are appreciating is that the ecosystem is getting more mature, and we have player like Miromico that provides hybrid base station, LoRaWAN gateway and Mioty base station. And actually, we have a question about this as well. Who besides Miromico provides hybrid base stations? Now we ask Liliane to mention their competitors.
Yeah, of course, that's not an issue. So, of course, steel metering has the ISAR gateway. Vitra, I believe, has support for both protocols as well. Swissphone, I believe, might as well. So that there are a couple of different providers. So it's definitely not just a one solution from us.
That's great. Any other question? If this is not the case, I thank again our, oh no, yeah, there is one. It's always like that, no? I start the final greeting and new question. So there's another question. Thank you, Sergey. He's asking, could you please give all list of manufacturer who do meters with Mioty? Well, I don't know if I can try to answer the question. I don't know if in the Mioty Alliance website, is it possible to find a comprehensive list?
Yes.
If not, for sure, you can get in touch with Alliance and ask for that. I don't think that both Stefan or Liliane know about the full list. But yeah, this is something I can share. The link of the Alliance website. Give me a second here in the chat. It's here. Okay, back here, and yeah, you can check in Mioty Alliance website if they provide a list of device, and of course in the sector you are looking for. And there is another question. Yeah, can I get the recording of this session? Yes, for sure. We will share the replay of this session probably already tomorrow in our YouTube channel. I look now, second, for YouTube channel. You also can find previous webinars as well. So give me a second, I will share the link of the channel. Sorry, I was not ready with that link. Okay, so here you have this link on our YouTube channel, LoRaWAN YouTube channel. You can find the previous webinar, probably tomorrow or in 2 days, the replay of this webinar. And also, please feel free to contact us if you. I think we can share the slides as well if necessary. Just get in touch with me. I share my email or with one of our speakers, and we'll be happy to share the slides as well. We have another question, two more questions. What is Mioty's install based in the US market? Now, this is something I don't know actually. I don't know if any of you know the answer. And next question is, any example of an end device that we can update its firmware to enable sending Mioty messages? Well, now we have so many questions. Let's start with these two. US market. Do we have any numbers from the US market, rough numbers?
I'm not sure about the total installed numbers, but I know that the Vitra gateway is already FCC certified, and there's also a TI system on module, I guess, which is pre-certified for easier FCC certification. So yeah, Mioty is definitely in the FCC market. Lily, do you want to add something?
Yeah, we have one customer that is in the US, and then another customer that is in Mexico so far. But also our gateway is not yet US 915 or FCC certified. So I'm sure there is much more out there
that we don't know about. Yeah. And next question is about an example of an end device that can be enabled can be Mioty enabled through firmware update?
Technically speaking or practically speaking, because technically speaking, any LoRaWAN device that would have an interface, so either like a physical interface or firmware update over the air, could later support Mioty uplink messages. Practically speaking, we would have one device, but I'm sure other manufacturers also have other devices. For us, that would be the Miro Insight, the temperature, humidity, CO2 indoor room monitor.
On GitHub, there's also a source-free version of the Mioty endpoint where you just can use it with the RF hold module and a PicoPi. It's very easy to build your own base station or to build your own Mioty device. Just download the codes, get those two modules, solder them together, and then you are ready to start.
Thank you. Next question. Could you tell us more about your strategy for achieving better coverage with Mioty? This is, yeah, better coverage, I guess, is not a technical question in this case. It's more a question of how, let's say, read is. Well, I'm reading this way, and please give a clarification, because if it's technically speaking, probably Stefan is the best person to answer this question. Is let's say business-wide speaking. So in terms of dissemination of the technology, in the coverage is there. It's always private coverage, so you can build your own network and cover your area. It's not like, for example, Sigfox in this sense, that is already, say, the coverage is provided by a third party, a provider. In this case, you can build your own private Mioty, but it is the same with LoRaWAN. I have to say, it's you can build your own private network also. It's actually best practice. It's considered best practice. Technically speaking, Stefan, this question is for you.
Yes, if it goes for network coverage, just build your own network with your own base station, search a very high point in the city, put a good antenna with a high gain in front of it, and then you get a very wide coverage. Mioty always uses the wide coverage mode, so we always have the full sensitivity. That's not a problem, and there you can achieve it. In future, there will also be city and nationwide networks from smart cities. We have a lot of that are in Germany that have their own networks right at the start, and they are not only doing the metering business, but they're also doing smart city things like flood level monitoring and parking. So yeah, in future there will be much more Mioty networks available. The Mioty Alliance has just grown 5 years old, so it's still a new alliance, but we are getting bigger and bigger every year, and you are free to join.
Great. Also, the call to action is very it's very good. Next question is there a network server that supports both protocol? And I can answer that. Yes, LoRaWAN for sure. Our hybrid network management system allows to manage both LoRaWAN and Mioty infrastructure. So absolutely. And I think that, to be fair, that is also Raysiot that providing this service. And as far as I know, these are the only two ones. Another question. Now you see people. It's well, many other questions. There is, so is there a network server that support both protocol? I've already answered that. What's the Mioty install base? You have answered that. Okay. Okay, is Mioty already being used in real-time web application? We answered that. Okay, so there is one more question, because they are both, sorry, in QA and chat. Capacity WRT Mioty versus LoRaWAN, considering 8-channel gateways. Also, what will be the minimum sending time interval if we are looking for RTLS-like applications?
So In Mioty, we have a 200 kilohertz channel in Europe and a 1.5 megahertz channel in US. So it's the band. No, it's 2 channels, but in the 2 channels, we have much more capacity than LoRaWAN with its chirp technology in the 8 channels. Maybe you reconsider the slide where the LoRa chirp spectrum signal takes much more space in the spectrum than the small Mioty bursts. With Mioty, we also use the 1% duty cycle band, and you are capable of transmitting 99 messages per hour from one device. But for one base station, you can receive 3.5 million per day, so you can do a lot of devices in one cell.
Thank you. Any other questions for our guests? Wait a couple of seconds more to give you time to type in your question if you have. In the meantime, let me thank again Liliane and Stefan for being with us and for also answering our questions and solving our doubts. Feel free to get in touch with them. I don't know if they want to share their or a contact email, or I always encourage you to get in touch on LinkedIn with our speakers. And yeah, that's all from us. I hope to see you soon with our next webinar. Thank you to our audience, of course. There is a nice message from George. Thank you, guys. Wish you success. Thank you. This is a very good wish for the new year and word. Oh, there is another question. Can we have some estimates? If 100 devices are there and 1 gateway, what can be the fastest rate? 10 seconds? Stefan is doing some math, I can see from the face.
I'm not totally sure what the question means. So typically, when you have the round trip delay, I'm not sure. I need to do the math, but when I just knew one more number from the base station side, so the endpoint can transmit 100 messages per hour, and the base station can transmit 80,000 ACKs per day. So if you divide them by 4, by 24, you have.
And there is another question. When you compare to LoRaWAN, you only consider spreading factor 12 or all data rates?
No, when you compare the capacity, there are some research out there from Semtech where they say how much messages they can receive in a mix of SF7 to SF12 messages, so all in between. And typically there are more SF7 messages than SF12. And even with this mix, Mioty and the 8 channels, Mioty is capable of receiving more messages. There is also a study out there from a university that tried to compare those 2 technologies on a very high educational level, and it's very precise. So if you're interested, just reach out to me.
Yeah. I think that's all, or maybe not. Thank you anyway, because I'm really happy to see such an interest on the topic. This is very encouraging for us to keep going with our webinars. And before I share the link to our YouTube channel, and you can find our also previous webinars. There was one dedicated to Mioty as well when we presented Mioty Go as a solution to test and simulate Mioty infrastructure. So you can also use that to test, and yeah, of course.
Yeah, and build your own base station with that. That's pretty cool.
Yeah. Absolutely. I think that's it. Thank you again to our audience. Thank you, Liliane. Thank you, Stefan. And thank you all. See you next time. Bye.
Thank you, everyone.
Bye bye.